Emostel.
You're welcome to this video. All right, so we've done a couple of videos before now talking about the first set of videos, about 8 videos talked about graph, and then a few videos too talked about measurements. Now this one is going to be based on the topic error handling or error analysis. Okay, so yeah, but before we go deep into this, the question is that what really do you think causes error in measurements? Error may originate from different sources, okay? So we have error in measurements, error in doing this, error in doing that. All those errors happen because of one thing or the other that didn't go so well during the measurements. Sometimes it's the fault of the measuring instruments, and sometimes it is the fault of the observer, and sometimes it is the fault of the environment. All right, so in this tutorial, we are going to be talking about the different kind of error that we have during, that you can encounter and how to correct them. You understand it now? So that's what we're going to be talking about here. Okay, so welcome to the video. All right, now, the two main types of error, that is the categories of error that we have in physics experiments or physical or laboratory experiments, they are grouped into two, or they are categorized into two. We have one which is called the systematic error, and then we have the other which is called the random error. You get? Now, the systematic error is due to factors that can be observed, factors that can be pointed, factors that can be noted, factors that can be seen. One way you can remember systematic error is that it is usually error that is dedicated to error due to the measuring instruments. That's the English you can use. Okay, systematic error is the error that arises due to the measuring instrument, while the random error is the error that arises due to human factor, environmental factor, just natural causes. You get what I'm trying to say? So for the systematic error, is error dedicated to the measuring instrument, error that sprang up from either the measuring instrument itself or the use of that measuring instrument. And then the random error is error that arises from the human factor, okay, and then or environmental factor. Do you get what I'm trying to say? Okay, so that's why I use the word natural, okay, like things that spring up from nature. I'm going to explain everything anyway, so let's just quickly talk about each of these one after the other. Okay, now the very first one here is the zero error. Okay, what is zero error? Sometimes you notice that the zero marking of your measuring instrument, the pointer of your measuring instrument is not coinciding. It doesn't coincide with the zero marking. You know, the thing is meant to balance at zero before you measure anything. It is during your measurements that the pointer will shift to other values of the scale. Do you get what I'm trying to say? For instance, you want to buy chicken at the cold room, and then it is sold per kilogram. You know that machine that they use to measure the kilo. You get? So if the end of that machine does not coincide with zero, maybe the stuff is like this. Okay, you know, you have the whatever is it, the tray on top, and then, okay, so let's say this is the zero marking, and then the pointer is supposed to be on top of the zero normally, but you have a situation whereby the pointer is like this. It's not merging, it's not balancing with the zero marking the way it should be. And then this, when you know that any measurement you take with this kind of condition, that measurement is not going to give you the correct value. So how do we correct this? Some of these instruments have adjustments. Like this one precisely has an adjustment. The moment the pointer is deviating away from where it's supposed to be at the zero marking, okay, there is something you can use at the back to adjust it back to the zero marking before you start measuring. So it is the error that arises due to this kind of instrument not balancing or coinciding with the zero marking is called the zero error. Do you understand that? Then it also happens with all these micrometer screw gauge. you know, where you have a level of the screw, the larger gear or whatever we call it, it's not coinciding with the smaller one, the zero marking of the smaller one. You can have all those kind of error. Whenever you have stuff like that, okay, just that's a situation whereby before the measurement kicks off, the pointer is not balancing at the appropriate point, at the appropriate 0 point. That kind of error is called the zero error. You understand? So we move on to the next one, the backlash error. Well, backlash error is error due to wear and tear. Okay, maybe your instrument is like it's old. Okay, the instrument is old, or it has been used and it is worn out. So that kind of instrument is most likely to give you an error reading. Okay, so one of the ways to control the backlash error, that is error due to wearing and tearing of some parts of your instrument, one of the ways you can control it or reduce it or avoid it is by making sure that you turn your instrument only in one direction. So that wearing and tearing usually occur because there is a part of that measuring instrument that is always rolling, or always spinning, or turning. Do you get it now? And then when that spinning or turning happens, frequently over a period of time in different directions, it will cause wearing and tearing. Okay? So one of the ways to correct the backlash error, okay, error due to wear and tear of some parts of your measuring instrument, is to make sure that your instrument is turned only in one direction. So with that, it takes long before that kind of error will begin to happen. But if today it is turned this way, tomorrow it's turned another way, today it's turned this way, tomorrow it's turned another way, and all of that. So friction can cause some kind of stuff. It is not all instruments that can have backlash error, but there are some kind of instruments that involve movement of some parts as a way of measuring something. Okay? For instance, now, maybe like the hanging mass, God, what's the name of this instrument? That you used to, the weighing scale, but in his own case, you have to hang it. I'm very sorry about this. I seem to have forgotten the name. Okay? So if it is meant to measure the weight of an object, okay, by suspending it. Do you understand? And then in that case now, the spring inside will move, okay, which will move downward. The downward movement of the spring is what will be measured on the scale for you to know the weight of that object. Do you get it now? So that one too now, it moves only in one direction. So although when you release the weight, it will go back, but the going back, the weight or the force with which it goes back is different from the force with which it goes down because of weight, due to weight. Do you get it now? So that one now, backlash error may take a little bit of time before it begins to happen to that kind of instrument. But there are some other instruments like that will involve you moving some parts. Just make sure that in that kind of case, turn your stuff, whatever is it that you turn concerning that instrument, turn it only in one direction to ensure that it lasts longer. So that is how backlash error is corrected. Then end correction error. Well, if you are not careful, you will mistaken end correction error with zero error. Okay, but the two of them are actually the same. But what is different between them is how they are being managed. You manage zero error by by adjusting the mark to balance properly on the zero marking before you start using. But for the end correction error, you cannot do that. Okay, for instance, if my wristwatch is faulty in such a way that the hand of the watch is not balancing properly on top of the marking, it is balancing like a little bit of after the marking or before the mark, okay? If you have that kind of instance, you cannot correct it. You cannot lose your watch does not have a lever at the back like this one, with which you can adjust it back to zero. So once that fault happens, it's like that. You cannot do anything to it except if you take it to a watch repairer and then and all that. But let's just assume you cannot touch or open that watch. What would you have done to correct this kind of error? Okay, you will notice, to correct it is that what you do is that you take note of the lag, take note of the difference, which means if the thing is like off the mark by a particular step, so anytime you take a measurement with the instrument and you get a value, okay, you just compensate for the value. You will add or subtract the lagging or the excess, okay, from the actual measurement you get to get the correct reading. So if, for instance, this is marking 1, 2, 3, 4, whatever, and before I start my measurement, this thing is already a little bit off the 0 mark. Then maybe after the measurement I got, okay, after the measurement I got something like this, okay? I know all I will do is that I will subtract the excess value here from the final thing I got here to be able to get the real value that I was supposed to measure, that the instrument is supposed to measure. You understand it now? So that's how you correct that kind of error. You correct it. Then if it is something that is lagging, that is it's at a point before the actual point of coincidence with the mark, okay? Then it means any measurement you take, you add the deficiency to it to get the actual value. So if it is at the back, you add. If it is overly, then you subtract. You get that gist. So that's how to correct this kind of error. Then the next one is the error due to change in instrument parameters. This one usually happens with instruments like that involve some things that can change with time. Okay, the best example I can point to at this moment is battery. If you are performing an experiment on electricity, and then in that experiment, you leave your battery on for a long time during the experiment, okay? You are going to have an instance whereby the battery, maybe at a stage, after some time, the battery will begin to run down. The moment the battery starts to run down, be rest assured that the measurements you are going to, the readings that you are going to get from the meter, whether the voltmeter or the ammeter, okay, the readings you are going to get will not be the correct reading because the battery that is powering the experiment is already running down. So one of the ways to correct this kind of errors is just to make sure that anytime that parameter, okay, is not in use, you disconnect it. Battery in this case now. So while you are arranging or setting up your instruments, you just try and make sure that you turn off you disconnect the circuit so that the battery will not be running down. Okay? So any other kind of instruments or experiments you are performing to that contains instruments that their parameters can change with time, okay? You find a way to correct that error, that instrument, so that you will not, anytime you are not using it, you disconnect it. When you are using it, it's only the time you connect. Do you understand it now? So that is the error due to changing instrument parameters. It happens not only to batteries, it can happen in a few other kind of experiments too, but mostly experiments having to do with electricity and heat. So for instance, now if you're performing an experiment on and you are trying to find something related to heat, okay? If you leave it for too long, the stuff can lose heat to the environment, and then you are not going to get the correct answer. All those kind of stuff like that. You get what I'm trying to say? So that's the error due to change in instruments and parameters. Then the next one is defective calibration. Defective calibration happens in the situation whereby that one usually comes from the manufacturer. Okay, if a manufacturer manufactures a ruler, if you buy a ruler from a particular company, for instance, and then the thing is not, the labeling or the marking or the graduation on the ruler is not totally accurate. If you buy such kind of ruler and you use such a ruler for your measurements, be sure that you are going to get wrong readings. So people who produce rulers or who produce measuring instruments, they usually calibrate it against a standard one. They will check the measurements against a standard measurement in a lab to be sure that it is the same reading that it gets before they now begin to sell it out. But a situation whereby there is a fault in the calibration, they didn't calibrate it properly, they didn't balance it properly with the standard instrument before they sold it out or before they start producing more copies, then if you buy that product, as a measuring instrument and you use it to measure anything, you're going to get wrong readings. Sometimes it is not about about buying a product or about something. Some instruments too, you have to set them to some particular values before you begin to use them and all of that. So things happen like that too. But the moment there is a faulty calibration, you didn't calibrate the instrument properly and you begin to use it just like that, then it's going to produce a wrong reading. So that's that. Then the next one is faulty observation. All right. So anyway, this one about faulty observation is actually supposed to be categorized under random error, left me, but well, the course material added this one to it. All right, so the faulty observation usually comes from a situation whereby sometimes it happens from this parallax error. We call it like parallax error in a physics lab, for instance. Now you want to measure if you are doing maybe you want to measure the length of something or whatever, or distance or something. You want to take the measurements, okay? If you place the ruler on top of the table, you need to make sure that your eye level is parallel with the points that you are trying to measure, to be sure that you get the correct thing. Because if you look at it from the side, you are most likely to get a different reading. Look at it from another side, it's going to look like it will change. But the one that is correct is the one in which you check it, you observe the reading directly with your eyes directly parallel to the thing that you are actually reading. Do you understand it now? So if you don't do that, if you don't observe your measuring instrument properly, you are most likely to get a reading that has error. Do you understand? So that's that. Now we move on to this next one, which is the random error. Error due to human or natural environmental factors and all. Okay? It could be observational, it could be environmental. Observational, which means it comes from the observation of the person that is carrying out the experiment. Okay? Okay, let me just put it like this. If you take the reading of a pendulum, maybe you allow your pendulum bob to swing 20 times, okay? And then you record it. The question is that why must it swing 20 times? Why can't we just allow it to swing only once and we record it? We allow it to swing 20 times before we take the recording, so we cannot take the average time as what? As the time for 20 oscillation divided by 20. Because it's covered 20 oscillation. So for us to know the time for one oscillation, which is the period, we'll divide the time for 20 oscillation by 20. So which means we are looking for we try to derive the average time. Do you understand it now? So this is because due to human error, if you do it only once, there is tendency that once you did it will carry error. It's either you pull the string too much, or you pull it too small, or you didn't something. You understand it now? And then so just to eliminate the tendency of those errors is the reason why you will have to allow the thing to swing up to 20 times, so that at least during that process, some things would have balanced out, and then all of that. So the value you eventually get will be close to the expected value, something close to the value it's supposed to be. Do you get what I'm trying to say? So then, that is why some experiments are done, like you repeat the same thing up to 2 times or 3 times, and then find the average of it before you now take the actual reading. So let's say that I want to be so accurate with my readings and of the simple pendulum experiment. For each of the reading of the length of the pendulum, you take, when the length is 100 meters, you allow it to swing, then you reduce it to 90 meters, you allow it to swing, you reduce it to 80 meters, you allow it to swing, and all of that, okay? So if I want to be so accurate with my measurements, even before I reduce the length to another length, before taking reading, the particular length, the initial length I took, which is like 100 centimeters, I will make sure that I do it up to 2 or 3 times. And then get the most accurate, the one that, if I did the first one, I got 20, so the time for 20 oscillation, I got maybe 10.2 seconds. I will do it again for the same length. I'll allow it to swing again. Maybe I'll get 10.3 seconds. It's still more like it, right? I will do it again. Then I can get maybe 10.2 again. Then I will know that, okay, it's either I stick to 10.2 because I got it 2 times, or I take the average of the 3 of them and I get the median value as my measurement. So that one will now be sure that, okay, fine, you are precise. That is precision. But if you take the first one is 10.2 and you take the second one 10.5, you took the third one, that one 13.7, it means that there is problem with you as the observer. There is an observational error. Observational error is something that is almost inevitable. Okay? That is the reason why we need to now look for a way to sort it out. Hence the next topic that will follow this. Okay? But then the thing is that one of the ways to sort it out is to find the average value. Okay, to control observational error, you find average value you repeat the same measurements at some amount of time, then look for the measurements, the values of measurement that you got that are close, the ones that are closest to each other. So which means if I do a swing and I get 20.5, I do another swing, I got 20.6, and I do another swing, I got 30.2. I would rather stick to 20.5 and 20.6 and leave that 30.2 because the distance between all of them should not be more than 0.1, highest 0.2. Do you understand it now? The difference should not be more than. So you pick the one that the values are very close, that they are either no difference or the difference does not exceed a particular value for precision. That is the one that you now pick as the measurement. You say, okay, fine, it's more like it, or more likely to be that value as a true value. You understand what I'm trying to say? So that's that aspect that for the observation. The environmental one is the one that happens due to environmental factors. For instance, you are performing a single pendulum experiment and breeze starts to blow. You know that thing will begin to blow, it will blow the instrument and it will be swinging in different directions. It will not give you the accurate value. So environmental factors can alter your experiment in several ways. For instance, now, Ohm's law, when you are just trying to do electricity, this thing, but heat from the environment can alter your measurements. That's the reason why they will say, provided that temperature is kept constant. So they always make all those laws with the awareness that environmental factors can alter the measurement. So that's why you say, okay, provided that so thing did not happen, provided that so environmental factor did not happen, then this thing is equal to this, or this thing is proportional to this. You get what I'm trying to say? So environmental factors like breeze, like heat, temperature from the environment, and many other factors can also alter your measurements. So error you can arrive at error from that factor. Okay, but observational and environmental, there are things that you almost cannot control. You almost don't have control over it. You can manage them to a great extent. For instance, if I want to perform a simple pendulum experiment, I would rather on my AC and close all windows to make sure there is no way breeze will blow that stuff. Do you get what I'm trying to say? So there are some measures you can take to control random error. But despite that, errors still arise one way or the other because you cannot really control them 100%. So you need to the way to now manage the situation after you have controlled the situation, the way to manage the readings is by taking some kind of statistical measurements. That's like taking average, looking for the deviation and all of those things, which are the things we are going to talk about in the next video. But for this video, I believe that you've understood the different kinds of error that we have, and then you can really be able to identify them and answer questions on them if you have been asked in your exam. Okay, so that's the answer for that. If you have any question, feel free to talk to me, and then please don't forget, if you are watching this on YouTube, subscribe, sharp, and then like the video so that I can give you a thumbs up. And then I can be happy that, my viewers are liking it. And please, if you have any complaint, feel very free. Just send your complaint to the phone number that appeared at one time or the other during this video. And then please just chat with me and then I'll respond. Okay, or any other person among our team will respond to you and then we address the situation. Okay, so with all that being said, see you in the next video. Bye.